everybody, it is Miss Phoebus and I am back for another design mathematics lesson, and this is lesson 6. This lesson is about an ancient artifact, and there is a picture of it. It is actually on a stand. The orange and the cream pieces underneath are a stand to support this artifact. So I'm going to have you, if you haven't already, I'm going to have you go in and do the lesson 6 part 1 assignment, and you are actually going to make some predictions. You're going to, and you have a picture of this in that assignment, you are going to make some predictions or some educated guesses. What do you think this object is made from? Where was this object found? And what was it used for? So I want you to stop the video. I want you to go and find that and then go ahead and fill that out. And it's okay if you're wrong. I want to see all the creative ideas that could possibly come from your brain, wondering what this very old and strongly believed to have been used for mathematics artifact is. All right, if you are back from doing that assignment, again, I'm looking forward to reading and seeing what kind of creative answers you have. I'll go ahead and tell you that this artifact is called the Ishango bone. And so it is made out of bone, and we're going to talk about that in a minute and go into detail with it. But this artifact is one of the oldest pieces that we have that we believe is used for mathematics. So this Ishango bone, it was found in 1960 by Belgian Jean de Heinzelen de Brockhourt. While exploring what was then known as the Belgian Congo, now it's called the Democratic Republic of the Congo. And so it's kind of Central Africa. And so there is a picture of the guy that found it, de Brockhourt. And it is a bone tool dated to the Upper Paleolithic era. It is a dark brown length of bone. It is the fibula, which is a leg bone of a baboon, and somebody had a sharp piece of quartz affixed to it at one end, perhaps for engraving. So it's actually probably one of the very first styluses or pens or writing instruments of, that we know of, the oldest one. And so the Ishango bone has a sequence of notches that was first thought to be just a tally stick used by Stone Age Africans. However, according to some scientists, the mark suggests a mathematical prowess that go beyond just the counting of objects. So they were counting something that was very, very, created a pattern. So we have a mathematical pattern that goes along with these markings, just not any kind of markings. And so if you look at the patterns, we have patterns of 3, 6, 4, 8, 10, 5, 5, and 7. And then you have these kind of prime numbers, 11s, 13s, 17, 19s, and then you got 21 and 9 in there as well. And so whoever, it is believed, whoever was making the bone was familiar with prime numbers and as well with addition by duplication. So you're talking about 2 5s make 10, 2 4s make 8, 2 3s make 6, and so on. And so this is the front and the back side of the bone. So this is like if we had rotated it around, you could see all of these markings are on one piece of bone. So we're talking about just different kind of notches. And so it looks like we have an understanding of multiplication and division by 2. And then you get into odd numbers, 9, 11, 13, 15, 19, and 21. And then the numbers in the left column are all the prime numbers between 10 and 20. And those on the right column consist of 10 plus 1 is 11, 10 minus 1 is 9, 20 plus 1 is 21, 20 minus 1 is 19. So you've got those numbers that are surrounding 10 and 20, which are, they are 10 is what we count by because we have 10 fingers and 10 toes, and so that would make sense with 10 and 20 as well. The numbers on each side of the column add up to 60, with the numbers in the central column adding up to 48, and both of these are multiples of 12, so again, suggesting an understanding of multiplication and division. The Ashango bone was studied by Alexander Marshak, an archaeologist from Harvard University. Marshak did not believe there was a high level of mathematics in ancient Africa, but he did conclude that the markings on the Ashango bone constituted the charting of a lunar or moon cycle. And the Egyptian scholar Charles S. Finch states that there is no reason that the Ashango bone cannot be both a lunar calendar and a sophisticated math tool. And so when you get into lunar calendars, you actually, and gentlemen might not find this very interesting, but for the ladies maybe so. The women's cycle that they use to, get pregnant and give birth is usually based on the lunar calendar. And so if you are in a culture where you are trying to procreate, you're trying to make little babies and try to have lots of them so that you can survive as a group, it's good to know when the calendar, when your cycle is about to happen. And so if you know what's going on with the moon, even when you can't see it, right? Think about the moon being behind clouds and things like that. If you know what's going on with the moon, and then you can also attribute that to knowing when the best time to start making babies is, then, you kind of have this idea of, maybe the mathematics behind the lunar calendar might be right. And maybe even the person that is keeping up with this might even be our first woman mathematician. The thing is, we don't know. We don't know who made it. These are all guesses. But I like to think that it is something that is a math tool. So if Alexander Marshak is right, that the Ashango bone records lunar cycles, then African women may be the originators of mathematics in Africa. Women have an unmistakable connection to the moon. Their menstrual cycle, like the moon, occurs every 28 days, with this being the most obvious reason that lunar or moon charting would be necessary for early humans. By charting their own body cycles, which are analogous to the moon cycles, African women may well have developed the time consciousness and time sensitivity that are necessary for agriculture to develop. So you're getting into seasonal changes and things like that. Dr. Charles Finch reported that when the pre-dynastic graves of ancient Egypt were opened, so this is before we have all the pharaohs in Egypt, we have still graves before that, before all the pharaohs came about. The field researchers made note of the superior wealth in the graves of the females. In addition, the female figurines added to the graves of the deceased outnumbered the male figurines. There's been speculation that this is because of the work that women do in a family setting, but it may also be because the women were greatly honored by many African communities for having introduced basic mathematical understanding. So I have a little video to show you. I'm going to put that on the same page at where this video is, and you can kind of watch and see how big the bone is, what it looks like for somebody to hold it, and then kind of how it's made its way into popular culture a little bit. The movie that they show that inspired the Ashango bone inspired part of the movie is kind of a little bit of an older movie. It's called 2001: The Space Odyssey. But if you ever get a chance to watch at least part of it, it's definitely a classic. It's a space opera. Okay, but that's the end of this video, so go and watch the other videos so you can get a good feel of what it looks like and the size of it. That's what I find really, really amazing. So thanks for hanging out with me.